Hi, I'm Andrea and welcome to Productive C#. In this video, I'm going to talk about interpolated string handlers in C#10 and on S6. I want to start by showing how the way the compiler treats interpolated strings has changed from .NET5 to .NET10, and I want to show you how you can write a custom interpolated string handler. Here I have a console application targeted on S6, and I'm using a simple console write-line statement with an interpolated string that I want to print. When I run this code, you can expect this is printing A5, B3, and C2. I want to show you the decompiled source code when I'm targeting on F5 and when I'm targeting on F6 and compare the two. Here I'm using JetBrains.pick, and I have compiled the console application first targeting on F5 and then targeting on F6. So let me see the decompiled sources for .NET5. As you can see, the compiler automatically uses string.format to calculate the final string given a string interpolation. And that's what happened until now. The main disadvantage of this approach is that if you're using value types as parameters, you can see that boxing is required in order to be able to use string format. Also, if you look inside the string format, you can see that an array of arguments is also created. So this string format is not as performant as it could be and is using memory. What Microsoft wanted to do is to provide a more efficient way to generate the final string given an interpolated strings and make it the default, code that the compiler generates in .NET6. Now, let me take a look at the implementation in .NET6. As you can see, now the compiler no longer generates a string.format, but is using a new class called default interpolated string handler. You might be familiar with the string builder pattern. Effectively is using a similar approach. So you create this handler here, and then the compiler is calling append literal and append formatted in order on how the user created the interpolated strings, and at the end is calling the toString and clear method to generate the final string. So the default interpolated string handler takes two parameters, two integer values. The first value is the sum of the lengths of all the literal parts in this interpolated string. In this case, there is 3 strings of length 1, and the sum is 3. And the second parameter is the number of placeholder expressions that are present inside the interpolated strings. In this case, there are 3 different placeholders. So that's why these numbers are these. Then the compiler is calling append literal for every literal string inside the interpolated string, and then call up an append formatted with a particular type for each of the placeholders. It's simple as that. The main change is the implementation of default interpolated string handler that is very, very interesting to look into. That basically is very memory efficient, is extremely performant. So by simply upgrading your application from .NET5 to .NET6, you get a big performance improvements in how interpolated strings are handled. Before I get into the details of default interpolated string handlers, I can give you a very quick look just to have an idea of how complex it is. I want to show you how you can create your own custom interpolated string handler. So let me change this one to my console that I defined here. This is a simple class that contains a write line method, and this method is taking an interpolated string handler, and then it's calling the normal console write line. By changing this, I'm basically using repeat handler now to generate a final string given the interpolated strings. So what I wanted to do is an handler that change the behavior of how this interpolated string is generated, so that this number here is the number of times I want to repeat the previous literal strings, right? So if I run this code, this is printing A 5 times, B 3 times, and C 2 times. So I'm changing the behavior of how the interpolated strings is generated. So you can do whatever you want. So let me show you the implementation. Actually, before showing the implementation, I want to tell you why this compile, because you're passing a string, and this is actually a class. This compile because in C# 10 there is an implicit conversion between the interpolated strings and the handler. So there is basically an implicit handler conversion when you do that. This object, this class, need to satisfy some particular requirements. First of all, you need to use the interpolated string handler attribute to declare. Then you need to have a constructor that takes two integers, the literal length and the formatted count, as I described before. You need to have a method append literal that takes a string, and this method is the one that will be called for each literal strings in the interpolated string. And then you need to have as many append formatted methods you want that handle a particular type inside the interpolated string. In this case, I'm only handling the int type. And the implementation is probably fairly straightforward. I'm using two string builders internally. One to build a message that contains all the literal text. And then, as soon as I use a placeholder passing an integer, I repeat that message n times to the resulting string and clear the message. And at the end, I just return the string I want. So this actually implements the behavior of repeating the literal strings n times, inside the string. So the compiler, if I compile that and I go back to .pic, you can see it's now using your new handler, custom handler, repeat handler, and it's calling append literal a, append formatted 5, and so on, and then finally print it to the console. Okay? This is effectively how you can create a custom string handler in C# 10. Most likely you are not going to need to create your own interpolated string handlers, and you will just get the benefit of handlers, but just using the S6 and any libraries that Microsoft provide or any other third-party vendors provide. But what this custom way of creating string handlers provides is the ability to customize exactly how the final string is generated. You can even decide not to process particular sections of the interpolated strings for performance reasons. Think about a login library that doesn't need to calculate the string if the login level is not the one you want to print. You can actually do as many optimization you want under the covers, and so it's quite powerful. But I want to show you a few things more on how you can even customize this handler more. I don't go to all the details, but I want to show you at least a few things that are very important to mention. So in this handler I created, for example, I'm only handling integers in the placeholder. So if I use, for example, here a double 2.3, you can see I'm getting a compilation error saying that there is no way to convert double to int, and there is basically no append formatted double inside the class. So the compiler failed because it doesn't find a method that can handle that. What you can do is use generics append formatted and specify t, and then you can decide how to handle anything that is using a placeholder but is not an int. So in my case, if it's not an int, I'm just appending it to the message. So I will repeat that n times. So let's see what that means. I could do, instead of using C, I could use a double, and I say 1.0, for example. If I run it, now I'm getting 1 2 times. So this double is converted to a string, and I'm just adding it to the value. But for example, I could use a variable, let's say name Andrea. I can provide a variable here, name, and this is repeating my name 2 times, Andrea. Okay? So now the compiler knows there is a method that takes any type, and is going to call that when you're using a placeholder with a type that is not an int. But if it's an int, it's going to call the specific method that you provided. In addition to that, there is a way to specify parameters to the handler. And the way to do that is, let's say I want to have a separator. I want to add a separator between these sections. So after the 5 A's, I want to add a comma or a space into it. Let's say I want to change this code to accept a separator here. Let's say a space, right? I could take this parameter here, call it separator. Okay, but then how can I pass the separator to the handler? So there is another attribute that you can use that is called the interpolated string handler argument. That you need to pass the name of the variable you want to capture, and that means that the repeat handler now need to have an additional parameter in the constructor that takes that value. So I'm going to add it here, char separator. Okay, so if I don't do it, you will get a compilation error because you say, oh, the constructor repeat handler has 2 parameters but is invoked with 3. Okay, it's not super intuitive, but that's how you can pass parameters to handlers. And now when you have the separator, you can change your code to handle it. Okay, so let's say I'm going to create a new variable separator that I'm going to save in the handler, and then I'm going to actually add the separator every single time. So if I run this code, you can see I'm printing 5A space 3B's and then Andrea. I can change that to a comma, and I'm going to get a comma. Obviously, I have a comma at the end, so I should probably trim the separator. Okay, but that's to give you an idea that you can customize the handler to provide additional parameters and change the behavior based on that. You could even change how the final string is being generated and or skip portion of the processing. Okay, so this is what I wanted to show you about interpolated string handlers. There is also a way to handle formatting of various placeholders. So I'm not going to go into that. See in the references links to the documentation provided by the compiler team at Microsoft for more details. But what you really need to understand, I think is the most important thing, is that by upgrading to the .NET 6, you get automatically the benefit of using interpolated string handlers, because the compiler is automatically using the default interpolated string handlers in the .NET 6 to improve the performance of how interpolated strings are handled. You have the power to customize completely the behavior and create your own handlers. Most of the time you won't need it, but if you do, you now know how to create these sort of things. So now let me very quickly regenerate the code that use the default interpolated string handlers, because I want you to show you how it looks like under the covers, the code that Microsoft implemented in the default interpolated string handler. It's quite complicated. It can be quite an entertaining thing to do if you want to take a look in details. But under the covers is effectively using the same things I've shown you. So is created a class that implements interpolated string handler, and then define a constructor. Is using an array pool under the covers to allocate the memory required to generate the final string. And then you can see there is append literal method, and it's using quite sophisticated memory approaches to handle appending things in the most efficient way, and also appended formatted. There's quite a lot of design decisions they've made, but you know, it's quite a long class with a lot of code you don't need to worry about, but it's quite more powerful than string formats and a lot more performant. And that's everything I wanted to show you today. Thank you very much for watching.